Chris for the introduction, and thank you all for coming today. So as you said, I'm from UC Berkeley. I'm an undergrad going into my third year. And I have a part-time internship at Berkeley Research Computing, which runs the Savio Supercluster at UC Berkeley. We support researchers all across campus in all different departments. It's really great because I get to talk to people from all different domains. We have about 500 compute nodes, and they're all of various types. So we have GPU nodes, big memory nodes, CPU nodes, and different generations of those. One problem we came across was that a lot of the data collected by Slurm and the job submission process was not easy to query or ask questions about. We had a lot of questions about our cluster, like which departments are using the cluster the most. And this is important data for a variety of roles. For example, users want to know when they should submit jobs, which partitions they should submit jobs to. They want to debug their jobs. System administrators want to know about different problems their jobs, or different problems the nodes had, and query their history. And managers want to know like what kind of users are using the cluster, which kinds of nodes are being used the most. All this data is there, and it exists. It's just a matter of aggregating that all together. So Slurm command line interface is really nice. It provides a lot of information for us, but it's not necessarily the easiest for users to use. So this is an example of what you might get with sinfo. All the data is there. You see circled is various states of the nodes and then the list of nodes. So this is what we started with. We have all this Slurm data. You could spend about 10 minutes and put together some flags to filter this down to something more comprehensible, but it's not easy for especially new users or someone that wants to see this data at a glance. So yeah, this is what we're starting with. And now that we have a bit of motivation about the problem we're trying to solve, which is visualizing this data from our cluster, I'll go into the background about previous approaches that other people tried, something else you might do. I'll go over a high-level overview of our approach. The implementation details I'll leave for the paper, and all the scripts are in a GitHub repository under open source license. Then I'll go over some use cases and examples of some of the graphs we generated and the questions we answered. I'll go over some lessons learned, some things I might have done differently had I known, and some key takeaways. Then I'll talk about extending this usage beyond Savio. It should work fine for pretty much any Slurm cluster, and give a brief summary. So as far as background goes, there are existing visualization approaches for cluster usage data. If you do a little bit of research, you'll probably come across XDMoD, which is like an all-in-one solution for this. A lot of our data is not completely integrated into Slurm, so it would require additional work to write data shredders for all this non-Slurm data. Also, we didn't think the interface of XDMoD quite fit our needs. We wanted something that we could easily embed and present to users in documentation. XDMoD does provide lots of graphs that are really great for visualizing the Slurm data, but we were already introduced to Grafana by one of our teammates who was using it to check the file system performance, and he used Telegraf as a backend. So if you don't know, Grafana is a web interface for displaying data as graphs. You can plug in a variety of database backends. And we decided to extend upon our teammates' use of Telegraf. Telegraf is like a daemon that runs, and it collects all different kinds of data. There are already a lot of existing plugins, such as collecting CPU data, collecting memory data, and you can also write your own plugins. So that's what we did. So I wrote exec plugins, they're called, which run and at various intervals ingest the data, process it, and give it to Telegraf in a form it can use. And this data is all tagged with all the relevant information we want, so we can make the graphs. So as far as a high-level overview goes, on the left here in the green, we have the compute nodes and the master node. All the compute nodes in our cluster are now running Telegraf, and we've enabled the CPU and memory plugins. These all go straight into InfluxDB, which is a time series database. It can handle all this data coming in as quickly as it does. Also in green, right below that, is the master node. The master node is our Slurm controller, and there's the exact plugins I wrote that collect the Slurm job data and also correlate it with the other data we're interested in, such as the accounting data, such as the accounts department data, which not stored in Slurm. As you'll see in one of the use cases and examples, we want to correlate the time series data with the job data and query those both at once. That's not quite possible to do in InfluxDB since it's just a time series database, so we shuffle that over to Postgres so we can do relational database queries. Grafana is really nice and extensible and allows you to query and visualize data from both these databases. You could have one graph in the same dashboard using data from Influx, and on the same dashboard have data from Postgres in there. And then that's all presented to the user in a web browser on the dashboard. So the key takeaway here is, and the bulk of this project was correlating and visualizing the time series data along with Slurm data and other information, other metadata. So we decided to take a user-centered design approach to this, and we identified 3 key roles that people might have that might benefit from this dashboard. So of course there's your end users. These are the cluster users that are running jobs on the cluster. There's system administrators who are troubleshooting broken nodes, and they want to view stuff like node history. And then finally there's the managers who are wondering, how is our cluster being used at a high level? What kind of usage do we see, like based on department or based on account type? So as far as the end user goes, I'll show 2 examples. You can imagine the end users have like there's a workflow as they go through their job submission process. Right before their job, they're planning their job, they're deciding, what node should I run my job on? Do I need GPUs? Do I need CPUs? Do I need big memory? So they're deciding which nodes to run their jobs on, deciding submission parameters. So that's what I call the job planning phase. Then their job runs, and after their job finishes, they're either happy with their results, or maybe their job timed out and they need to do some debugging. So to help with the job planning stage, as I mentioned, there's several different types of nodes. In a lot of cases, users could use multiple different partitions, as we call them. For example, if they're just running a CPU job, they could use an older generation of hardware we have or the newer generation. Perhaps the newer generation would run faster, but it might have a longer queue. So at the end of the day, users just don't want to wait. Like, if you can use the older hardware and stay in the queue for less time, that's an advantage because you might end up actually finishing your job first. So that leads into the first graph. So on the x-axis here, you see there's the partition, and on the y-axis is number of available nodes. So at this particular moment in time, if you were a user either looking to run on Savio or Savio 2, which are both our CPU nodes, you might want to run on Savio because there's about 70 available Savio nodes and probably about 3 available Savio 2 nodes. So you'll be waiting in the queue for a lot less time if you run on Savio in this particular case. It can vary on day-to-day basis, which is why we need these graphs to be live updating and hopefully embedded in some sort of documentation. So then after your job's run, you might want to identify common issues with your jobs. A lot of users have problems where their job's not using the CPUs to their full capacity. Sometimes that means their job is disk bound or memory bound. You also want to view CPU usage over time on just the nodes used for the job. Telegraf already is collecting CPU data, as I mentioned, but this is CPU data for all time on all nodes. This is not easy for users to, they would have to go into Slurm and figure out exactly when my job started, exactly when it finished, and exactly what nodes it ran on if they wanted to figure out the relevant information for them. So we made a dashboard to put that all together. In Grafana, you can have a database query that gives a list of options, and they can select up at the top of the dashboard their job ID, or you can type it in because there's a lot of them. And it will filter all the graphs on the dashboard based on that job ID parameter. So these are 2 examples of data showed on this dashboard. On the right here, you see it identified which nodes were used for the job. And on the left, it figured out exactly when the job ran and got the CPU data for just that time. So if we were the users that ran this job, we might be concerned because it looks like it maxes out at about 50% utilization. So they're only using about half the cores. So they requested 2 nodes, so perhaps they could get away with requesting 1 node and using all the cores. Also notice there's a dip in the middle. That could be any sort of problem almost idle for a couple, like few seconds, and that's time that's wasted basically. So by looking at this graph, you can't tell exactly what went wrong, but it gives a good starting point. Slurm does, we've had users that have asked, like, is my job using all the resources to their full capacity? And we can tell them, you can look at Slurm's average CPU usage, but the average just tells you the average. It doesn't tell you what the CPU usage looks like. It might be at 100% for half the time and then 0 for the rest of the time, and you'll get 50%, or it could be something like this. So this is really useful for users that would want to debug their jobs. So another use case we had is a manager would want to figure out what departments are using the cluster. And we want to filter by any arbitrary condition, basically. We could ask which departments are using the GPUs the most, and we could also filter by which accounts are using the GPUs the most, or filter by specific partitions. So this is what so to do this, we had to tag all the job data with the account data. And then we come up with something like this. This is another graph from Grafana, and this is a pie chart showing CPU time. So CPU time is the number of CPU cores times the amount of time they ran in hours. And this is just for this cluster during this period of time. So in Grafana, you can select the time range you're interested in, and it will filter down the data for just that time range. So for whatever time range this was querying, material science was our biggest user. That's the big red section, and chemistry was our second biggest user. So this is really cool insight, and you can generate these graphs on the fly for whatever thing you're interested in. So you could be like, I want to filter this, but just looking at GPU nodes, or I want to filter this just looking at big memory nodes. And in the interest of time, I'm only going to show those three, but there's a lot of other questions we answered. For example, we have some HTC nodes, which are high throughput, and users can request a certain number of cores on those nodes, and we wanted to determine a policy, and we needed to know how many CPU cores do users usually request, and that was there. We can also ask, from the sysadmin perspective, when has a particular node been down in the past? You can query this with Slurm, of course, but it's great to see it as a time graph, and you can also correlate it with other nodes. You can layer these graphs, time series data graphs, on top of each other. We can also ask which node type should we buy more of. You can create a query that looks at the percent utilization of a cluster over a period of time. So we could see like the GPU nodes are at 100% utilization all the time, maybe we should buy more of those. And Grafana also provides built-in alerting capabilities. It has many, many outputs. So you can output to Slack, you can output to email, and you could set it up so it can check the CPU usage on the login nodes and then send alerts that way. So as far as lessons learned go, if I were to do this project again, I would want to focus on moving the data to Postgres. So in the way we did it currently is kind of slow. We run it every 24 hours and shuffle the data, so there's some delay there. Perhaps we could combine the time series database with all the Slurm data in real time, and something like timescale DB, which is Postgres but optimized for time series data, seems like it'd be suitable for that. Some good things we learned was that it's really easy to add additional data sources to Grafana. Going into this, we didn't originally plan on using Postgres. We didn't think we needed it, but we realized that we have CPU data, we have Slurm data. Why don't we put those together in a nice way for users? So it's turned out to be really simple to add additional data sources to Grafana, and if anything comes up in the future, it shouldn't be a problem to add anything else. We also learned that some of our ideas didn't work out so well. So we were wondering, is there a weekly pattern on cluster usage? Perhaps the cluster's mostly used on Mondays through Fridays, and then Saturdays are free. So we should tell users, hey, you should run more jobs on Saturday. But it turns out that it wasn't really easy to see a temporal pattern in cluster usage. One week, maybe Saturdays are free, next week they're the busiest day of the week. That comes down to just some users could use up the whole partition with one job submission. But the data is all being collected, so perhaps we could dive more into that. as far as going beyond Savio, the scripts I wrote should be able to collect data from pretty much any Slurm cluster with some minor modifications. As I mentioned, it's available under an open source license in the GitHub repository. At Lawrence Berkeley Lab, there are interns that worked with that are deploying these scripts to Laurentian clusters. We already have examples of this working on clusters outside of Savio. As far as future work goes, we still need to deploy this publicly to the end user. We imagine it will be really useful. I've already talked to some users who have asked for things like this. They've asked for easy ways to see which partitions are available. We just need to get the firewall rules set up and the self-certificates and everything ready. Grafana does provide the ability for anonymous access, and you can lock down the graphs so you don't have users using too many resources with the queries to the graphs. So you can lock down the time, so you can say, oh, we're only going to show the cluster in the last minute, so you're not querying too much data. I'd also like to add correlation with memory in addition to CPU data, because we can see CPU data over the course of a job. It'd be really great to see memory over the course of a job, because we have users running out of memory sometimes. And that should be pretty straightforward to do. We also want to use a better method for correlating accounts to departments. Right now our accounting system is based on Google spreadsheets. So I download Google spreadsheet and parse that, and the script that takes an account name and returns the department. That script can be replaced with anything that perhaps your cluster uses, or we're developing a REST API that will manage the accounts, so I'll switch that out for something that'll just make a REST API call. So in summary, Grafana and Telegraf in this software stack is useful for many use cases, from users to sysadmins to managers. You can ask it lots of different questions and it can provide the data. And it's really easy to add new graphs and data sources as requirements change. The ease of adding these queries and graphs inspires more data exploration. Going into this, we didn't have as many questions as we do now. So it's really great to better understand your data, and it kind of leads you to better understand how your cluster is being used. So, and finally, the Slurm data collection scripts can be deployed to other Slurm clusters in a pretty straightforward way. So thank you for your time, and I left a couple minutes for questions.